Hello and welcome to the Unit 8 Section 5 video on equations of circles. So we are going to talk about how do you write an equation of a circle. Just like you can have the equation of a line, you can have an equation that will plot a circle in the coordinate plane. And the equation of a circle is going to be based on the distance formula and the fact that all points are equidistant from the center. So we start with our distance formula and we then take our 2 points. So we are going to use the distance between the center of the circle and the outside part of the circle, and we are going to find what the radius is, because the radius is just the distance in the coordinate plane. And by taking our center of the circle and our coordinates hk and comparing that to our coordinates xy, we plug that into our distance formula, and then we just square both sides to get rid of the square root, and we have the equation of a circle. R squared is equal to x minus h squared plus y minus k squared, where hk is the center of the circle and r is your radius. So let's do a couple of examples. In example 1, we want to write the equation of circle A with a center at 4, -2, and a radius of 3. This is as simple as just plugging things in. The equation of a circle, start with that. Our hk is 4, -2, so we're going to put in for h 4, and for k we're going to put in -2, so we're just plugging things in. Our radius is 3, and then from here we're just cleaning up. Nothing to do with this first part. That's just going to be x minus 4 squared. The next part we're going to do minus and minus, which gives us a plus, y plus 2 squared. And then 3 squared gives us 9. So that is the equation of our circle. In example 2, we want to write the equation of circle B that passes through -2, 6 and has a center of -6, 3. What we're lacking here is the radius. So we can use the distance formula to find our radius. We are going to find the difference in our x's, so -2 minus -6 squared, plus the difference of our y, 6 minus 3 squared. So you do everything under square root, you get the square root of 25, so our radius is going to be 5. Remember, it has to be the positive version because a radius cannot be negative. And then, now that we have our radius, we have our center, we're going back to our previous problem where we do x minus h, which is -6, squared, plus y minus k, which is 3 squared. Make sure you're using the coordinates for the center, okay? Not the point that it passes through. And our radius here is 5. So we have 5 squared. All that's left to do is clean up. X plus 6 squared plus y minus 3 squared is equal to 25. Now that we know a little bit about the equation of a circle, let's use that to graph it, okay? So in example 3 here, we're given the equation of our circle. We want to make a graph of it. So there are a couple of different ways we can go about it. The first way is by making a table of values. Since the radius is the square root of 25, or 5, we're going to use plus or minus 5 and the values between for our x values. So what you'll do is you'll set out your x values, and then you're going to plug those into your equation to find what your y values are. So if you put -5 into this equation, that's going to give us 25 plus y squared equals 25. Subtract 25 from each side, y squared equals 0. So y, therefore, would be 0 here. And that would be the case over here with +5. Okay? So I will let you go through the exercise of putting in your x values to find out what y is. When you put in -4, you get plus or minus 3 for your y value. The same goes for when you put in +4. If you put in -3, you get plus or minus 4. The same goes if you put in +3. And if you put in 0, you're going to get plus or minus 5. And you kind of see the pattern here. Let's plot the points and then we will connect them. So you have -5, 0. So -5, 0 is here. And then you have -4 plus or minus 3. So point here, point here. -3 plus or minus 4. Then you have 0 plus or minus 5. Then you have 3 plus or minus 4. Then you have 4 plus or minus 3. And then finally you have 5, 0. And then we can plot all of those points by connecting them. So you can draw your circle by connecting all of the points like so. And so there is the circle, and you can check it using a graphing calculator, or more easily, because you can enter the equation in just as it is using online graphing utilities such as Desmos. All right, so that took a little bit of work to graph. So let's take a look at a little bit easier method. So for this example, we're going to graph this equation of this circle. Well, let's rewrite this in this form. Remember, we have x minus h squared plus y minus k squared equals r squared. So this would be x minus -1 squared plus y minus 2 squared is equal to 3 squared. So here, our h and our k are going to be -1, 2, and our radius is going to be 3. So we start by plotting the center of our circle, -1, 2, which would go right here. Then we're going to use our radius to plot the points going up. So you go up 3, you go down 3, you go right 3, and you go left 3. And then from here, you can plot your circle by connecting those points. So this method is just a little bit easier to go through. All right, this last example is one that I'm just going to walk through because I want to show you a real world situation where we would use something like this. And we're going to use it by doing something called triangulation, okay? Meteorologists are planning the location of a new weather station to cover Osceola, Waco, and Ireland, Texas. To optimize radar coverage, the station must be equidistant from the 3 cities which are located on a coordinate plane at these points. So we want to know what are the coordinates where the station should be built, and if each unit of the coordinate plane represents 8.5 miles, what is the diameter of the region covered by the radar? So the first thing you would do is plot the 3 given points, which is done here, okay? Then we connect A, B, and C to form a triangle. Then we're going to find a point that is equidistant from the 3 points by constructing the perpendicular bisectors of 2 of the sides of triangle ABC. The perpendicular bisectors of the sides of ABC intersect at a point that is equidistant from the points A, B, and C. So that was done here, and you would have to use some construction methods to do that, which you have already learned. The intersection of the perpendicular bisectors is at -1, 1. Okay, so that's the first piece of information we're looking for. Now, what you can do is, after you draw your circle going around the 3 outer points, there are approximately 10 units across this circle. So the diameter of the region covered by the radar is approximately 85 miles. So I know I kind of went through that example fairly quickly, but this kind of gives you an idea of where you would see something like this utilized in the real world. All right, with the exception of the next section being constructions, that pretty much finishes off the content on this unit on circles. So the next section is circle constructions, which are basically just directions on how you do various types of constructions utilizing circles. In the next unit, we are going to get into talking about 2- and 3-dimensional figures. So we'll be talking a bit about area and volume and things of that nature.